So in this video, I want to talk about how to solve rational equations, and in particular, we'll solve rational equations by combining all fractions. Okay, so first of all, what is a rational equation? A rational equation is an equation containing rational expressions. Basically, an equation with fractions is what a rational equation is. Um, Now, I also want to talk about what it means to solve. So, to solve an equation means to determine the values of the variable that make the equation a true statement. Okay? So, the answer to an equation that's been solved should look like x equals dot 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 numbers, right? Or v equals, or whatever the variable is, you figure out what it equals, okay? So that's important. Also, when solving an equation, every step should be an equation, meaning should have an equal sign with expressions on each side. For some reason, I see a lot of people lose one side of the equation. Well, when you lose one side of an equation, it just becomes an expression, and you're no longer solving because you don't solve expressions. Okay, so I'll try to emphasize these things as I go through examples. Let's look at our first example. So here's a rational equation. It's an equation because of the equal sign. It has two sides, something on the left and something on the right side of the equal sign. And that tells us we're going to be solving. So our answer is going to look like, since our variable is x, our answer is going to be x equals something. So that's what our goal is, okay? So let's go through the process here of actually solving this equation. There are lots of ways to solve these types of equations, and I've taught it the way everybody teaches it, and I've taught it that way for years. But for whatever reason, it doesn't stick. So I'm going to try something different in this video where I'll teach it the way most students try to do it, because apparently that seems to make sense to students. So I'll teach it that way and hope that because it may be more logical than the usual technique, that you have more success with it. So what I'll do is I notice I have three fractions. I'm going to try to get all the fractions on the same side of the equation. So I have 8 over x squared minus 9x plus 20. And then I'll subtract both of the fractions on the right side. So minus 1 over x minus 4 minus 2 over x minus 5. And then notice that I'm not going to write nothing on the right side. It's still an equation, so I have to write equals 0. So don't forget this. A lot of people forget that. If you don't write the equals 0 part, it's not an equation anymore. Okay, now that all my fractions are on the same side, I'll combine them. In other words, I'll add them together. So I'm going to change this minus to plus a negative, and change this minus to plus a negative. And so now I'm going to try to get a common denominator with those three fractions. Before I do that, I need to factor my first denominator. And using the AC method or something, you'll get x minus 4 times x minus 5 plus, sorry about that, since I'm trying to get a common denominator, I'm going to multiply each of these three fractions by a form of the number 1. So we'll figure out what form to use here. Then I'll have my second fraction, negative 1 over x minus 4, times its form of 1, plus my third fraction, negative 2 over x minus 5, times its form of 1. And then still equals 0. I still need to carry that through every step. So I'm trying to make all of my denominators the same. And so what I notice is that I can make all of them into x minus 4 times x minus 5. And so how do I do that to the first one? Well, the first fraction. Well, its denominator is already what I need it to be, so I could use 1 over 1. Or I wouldn't even have to use this fraction at all. I could just leave it alone. The second fraction I'll multiply by x minus 5 over x minus 5, right? So what we've got here is two fractions that are now going to have the same denominator, and the third fraction needs the same denominator as well, so I'll use x minus 4 over x minus 4. And what that accomplishes for us is now I've got this fraction, which is 8 over x minus 4 times x minus 5, plus same denominator for my second fraction, x minus 4 times x minus 5. My numerator is negative x plus 5, plus my third fraction, same denominator, x minus 4, x minus 5. And my numerator is negative 2x plus 8. Now they all have the same denominator, so I can combine them all into a single fraction with the common denominator on the bottom. And the right side is still equals 0. It's still an equation that I'm solving. And on top, I just combine like terms. So negative x plus negative 2x, for example, is negative 3x. And 8 plus 5 is 13. Plus 8 is 21. Right? And so now what I'll do is I need to finish solving this. And maybe what I'll do before I try to solve anything is reduce this fraction. That's very common as well. So I'll factor out a negative 3 on top. And when I do that, it leaves behind x minus 7. And on bottom, I have x minus 4 times x minus 5 equals 0. Well, nothing canceled. You know, I factored, but nothing canceled. So now I've got to finish solving. How do I determine what x is? So that's the key here. How do we determine what x is? That's the question. The answer is to multiply both sides by the denominator. The reason is when you solve equations, you try to undo things. And here, what I've got is division by this denominator. So how do I undo that? I multiply both sides by my denominator. So I'll multiply the left side times x. Well, let me write it a bit neater. I'll add an extra step here. So I've got negative 3 times x minus 7 over x minus 4 times x minus 5. I'll multiply that by x minus 4 times x minus 5, which is over 1. Remember, this is not the same thing as multiplying by the number 1. You can do whatever you want to an equation as long as you do it to both sides. So the goal here is to get rid of that denominator. And so when you do that, on the left side, this all cancels when you multiply the two fractions, and you're just left with the numerator, negative 3 times x minus 7. And on the right side, 0 times anything, even this nasty fraction, is still 0. Now you can get x by itself pretty easily. So in this case, you could divide both sides by negative 3, or you could distribute the negative 3. Let's do that. Negative 3x plus 21 equals 0. And now subtract 21 from both sides. Divide by negative 3, and we see that x equals 7. Okay, so x is 7, and we finished solving this equation. Now, one thing I want to point out is the original equation way up here had denominators. Whenever you solve equations that have denominators, you better make sure that your answer, which in our case was what? X equals 7. You better make sure that if you were to plug that back into the original equation, that none of your denominators are 0. And in fact, this one works. X can be 7 because no denominators are 0 when you substitute that back in. Okay, remember if you try to divide by 0, it doesn't work. So that's why we have to make sure that this doesn't make us divide by 0 in the original equation. Okay, so let's sort of summarize what we just did. So to solve rational equations, combine all the fractions on one side. And when you do that, it leaves 0 on the other side. Okay? That was the first thing we did. Then the idea is to, once you get a single fraction on one side, then undo the division by multiplying both sides by the denominator. Once you've done that, there's no more fraction. And once there's no more fraction, you can finish solving. Oops, sorry. Finish solving using usual techniques. Okay? So once the fractions are gone, you can finish getting x by itself. So let's try another one. I'll go a little quicker this time. So we're going to get all the fractions on one side. I'm going to subtract the fraction on the left to leave me my 0 on the left side. And on the right side, I'll have 32 over. And I'm going to go ahead and factor that denominator because I know I'm going to need to get a common denominator. So I have 32 over x squared minus 16. I'm going to leave a space. I'm going to write 3 as a fraction, make it 3 over 1. And I'm going to have minus x over x plus 4. Now the reason I left a space is because I'm anticipating that I need a common denominator, so I'm going to multiply each of these fractions by their own form of 1. Also, this minus I'm going to change to a plus and shift my negative to the numerator. So I've just saved myself a lot of time by doing all that at once. You don't have to do it all at once though, do whatever you're comfortable with. Now my common denominator is going to be x plus 4x minus 4. So my first form of 1 is 1 over 1. My next form of 1 is x plus 4 times x minus 4 over x plus 4 times x minus 4. And my last form of 1 is x minus 4 over x minus 4. And so what I get is 0 equals my first fraction. So I'm going to multiply these guys straight across to get 32 over x plus 4, x minus 4, plus my second fraction, multiply these guys. What I'm going to do here is do this off to the side, do this guy off to the side. So I've got 3 times x plus 4x minus 4, which is x squared minus 16. And if I distribute my 3, I get 3x squared minus 48. So my numerator is 3x squared minus 48. My denominator is what I want, x plus 4x minus 4. And then plus my last fraction, when I multiply these guys, I'll distribute my negative x to get negative x squared plus 4x on top. And on bottom, I'll have x plus 4, x minus 4. So now my denominators all match. So I'll add them all together to get a single fraction with x plus 4. X minus 4 is my denominator. And on top, I'll combine like terms. 3x squared plus negative 1x squared is 2x squared. 32, oh, sorry, I have an x term. I've got my plus 4x. I'm putting it in descending order as I go as well. So the x squared terms first, the x term next, and then the constant, 32 minus 48 is negative 16. So if I were to factor 2x squared plus 4x minus 16, I'd pull the 2 out. And then if you factor the trinomial, you get x plus 4, x minus 2. So I'm just simply reducing my fraction like usual. So I factored the top. And when I do that, I see that my x plus 4's cancel. Okay? So now on top I have 2 times x minus 2, and on bottom I have x minus 4. And now I'm dividing by x minus 4, so I'm going to undo that by multiplying both sides by x minus 4, which is the same thing as x minus 4 over 1 if I write it as a fraction. So what happens on the right side is these cancel, and I'm left with 2 times x minus 2. And on the left side, 0 times anything is 0. So I've got 0 equals 2x minus 4. If I add 4 to both sides, I get 4 equals 2x. And if I divide by 2, I get x equals 2. Okay? Now, sometimes once the fraction is gone, sometimes you get a quadratic or higher degree equation. You would solve that by factoring, like we've done before, where we solved higher degree equations. So you may have to remember that. Also, x equals 2, if you look at it in the original equation, you can plug it in for these denominators, because that's what you would do if you wanted to check. You'd plug 2 back in for these x's to see if it works. And luckily for us, it doesn't make any denominators 0. So x equals 2 is an acceptable solution to this equation. I hope that makes sense. I hope it helps. You'll get a lot of practice adding and subtracting fractions. And all we're going to tack on to that now is how to undo division, and you undo division by multiplication.